these sequential circuits are called as sequential machines, right? Sequential machines. These are classified into two. One is Mealy machine, okay. The second one is Moore machine. Mealy machine, where the outputs of the circuit depends both on the current state of the circuits and inputs. The current state of the circuit and inputs, if the output depends, that is called as Mealy machine. And Moore machine is the output circuit depends both not only on the current state but also the previous state or the earlier states, okay, right? That is called as a Moore machine. So these two machines are typically used in optimizations or gate reductions, right? How to start to make this state diagrams, okay. State diagram, state means what is the situation, something we generally refer to, right? So let us assume we have two states, state A and state B, okay, state A and state B. So here state A, the last output was a 0 and the previous input is unknown. Last output was a 0, okay, and previous input is not known. The previous input to A is not known. So A is represented as a circular thing in which A is written, that is called as its state, right? Similarly, we have B and the last input was 1. Last input to this was 1 and the output was 0. Output was 0. The start of a new sequence possibly, okay. Capture this in a state diagram. So the previous input was not known, so consider this to be 0, okay, consider this to be 0, and the 1 was the input, okay, 1 was the last input was a 1, so 1 is the input and the previous input was a 0, previous input was a 0 to B, okay. So the output of B could start a new sequence, that is not set. This is how you write a state diagram, okay. So since the last input to A and output are not known, okay, consider both as zeros and zeros. This is how you mention a state diagram. So capture this in a state diagram was the thing that is given. Circles represents the states. These circles represents the states. Lines and arcs will represent transition between the state, okay, from state A to B or from A to A itself. If you draw an arc or a line, okay, generally arcs are drawn from the same state itself, lines are drawn from one state to another state. Notation: input and output on the line or arc specifies the input that causes the transition and the output for the change of the state, okay, output for the change of the state, right? So input for this is 0 and whatever the state change, okay, is caused by which variable? 0 here. Input is 0, state variable which caused is 0. Input is 1, state variable which caused is 0, right? So let us add C to the same diagram. However, C has detected input sequence 11, okay, which is the start of the sequence, right? So here we have to mention from B what is the output we can expect, don't know, it is not mentioned, okay. So here have detected an input sequence 1 1, okay, it has detected an input sequence 1 1. We are not bothered about the sequence which started the start of the sequence, that is what they have mentioned. But what is the B's output? Could be possibly 1 or 0. I am assuming it to be 1, okay. Which variable caused this? 0, okay. Which variable caused this? 0, right? Let us start with D. We have detected a third input to start the sequence, that is we can make it as all the sequences as 0 0 0 1 1 0 and 1 1, okay. So D has two more things. D D has two more things. We have detected third input in the start of a sequence A0. Now we have 1 1 0. From the state D, if the next input is A1, the sequence has detected A1 as the output. Okay, A1 as the output. So this is some statement that is given, based on which we can mention what is the output of D. Okay, if the next input is A1, the sequence has been detected and A1 is the output. If assuming A1 to be 1, okay, A1 to be 1, if the sequence end here, what is the input to A? We don't know. We don't know, right? If we consider this to be 0, okay, the sequence will be 1 1, right? So as we go much deeper into the state transition and state diagrams, we can understand how to mark the states and all. So let us add some transitions in between. Okay, add some transitions in between. In each state, the next input could be A0 or A1. This must be included. This must be included in each state. Okay, the next input could be A0 or A1. That is what the statement they have mentioned. Okay, so if first input, if the next input is for B, if I am planning to take one input from B, give it to A, that becomes 0 bar 0. Okay, so if it becomes from D to B, I am giving some transition, some input, okay, which is 1, which the 1 is creating one transition as 1. Okay, so that is, can be mentioned something like this. Similarly, from A to D, I am adding one more thing, which is 0, which has caused a transition of 0, so I can make it as 0 bar 0, right? So like this, I can add multiple transitions. Okay, so there is only a rule that follows a multiple transition, or the table that is given will tell you what is the kind of transition, right?